The circuit here is my comparator. As you can see, 2.5 volts is connected to the negative voltage with my potentiometer at the positive voltage. When I raise my potentiometer past the 2.5 volts, then my gain is going to be at a maximum and my potentiometer reads a high as its output, as you can see by the high LED, and when it's lower than 2.5 volts, the LED goes dim. Here's the derivation for my non-inverting amplifier, and as you can see, I used nodal analysis as well as the assumption that V plus equals V minus, and the current into the amplifier is 0, and the numbers turn out to be the gain equaling 1 plus R2 over R1. Here we have my unity gain amplifier. As you can see here, I have my potentiometer set to be going into my V plus, and my V minus is in a feedback loop for my V out. Now what this will do in the processing code is V out is actually going to be V minus in this case because it outputs over top of the bubble, and my V plus, as you can see, they both are the same for all numbers above around 1.8, and that is most likely due to the differences in the source voltage from 0 to 5 on the minus and plus respectively. Here we have my inverting amplifier, and our gain is negative 10. That is my 2.5 volts that's going into V plus. And from this, as we'll quickly see in the processing code, what's going to happen is it's going to plateau at certain numbers, but it's still going to be inverted when V minus is lower than 2.5, so as you can see right here, and then it jumps and plateaus again to around 1.8 volts again, and that's going to be the lower end of our amplifier, as you can see by last circuit. And then it plateaus at the top at around 4.2, which is the top end of our amplifier. This is the code that passes through processing. Here is my inverting integral circuit. We have the capacitor in a negative feedback loop and my potentiometer. When we go over to the processing window, what's going to happen is the integral is going to follow V minus, so V out is going to follow V minus when it's lower than 2.5 volts. And then when it's higher than 2.5 volts here, it's actually going to drop and plateau at 1.8 volts like we've seen previously. And when we go back below 2.5 volts, we're going to get that integral again, and that's going to be totaling the change in my green, and it's kind of lagging it behind, as you can see.